Ever wondered what puts the brakes on electricity? Let's talk about resistance.
So how do you actually control all that power? Turns out the answer is pretty simple.
It's kind of like a speed breaker on a road, but for electrical current.
Simply put, resistance is just the opposition to the flow of that current. It's a pushback.
So what actually determines a material's resistance? Well, there's a formula for that. Let's break it down.
First up is length. Think about it. A longer wire just means more resistance. Simple, right?
Then you've got area. A thicker wire is like a wider highway. Less traffic, less resistance.
And finally, resistivity. This is a material's own natural built-in opposition to that current.
For example, copper has super low resistivity, so it's a great conductor. Wood, the complete opposite.
And here's a fun one. Pure water is actually a really bad conductor. Add some stuff, and it works. Okay, so what's the deal with resistance versus a resistor? It's a common question, so let's clear it up.
Resistance is the concept, the property. A resistor is the actual physical part you put in a circuit.
All right, this all gets tied together by one simple but super important rule: Ohm's law.
Think of it this way. Voltage is the push, current is the flow, and resistance is the opposition.
Basically, more push means more flow, as long as the resistance doesn't change. Makes sense.
So who cares, right? Well, this law is how we control pretty much every electronic device out there.
And because it's so useful, we can rearrange it to figure out electrical power in different ways. So, to recap, resistance is the opposition, resistors created, and Ohm's law is the rulebook.
So, think about the device you're on right now. It absolutely couldn't work without them.